So, the goal of the Zephyr project is to make it possible for embedded system developers to target multiple microcontroller units or boards with the same code base. And at the moment, from their website, you can see that they support more than 800 boards. What this basically means is that you can build a firmware and deploy it on all of these 800 plus boards from different microcontroller manufacturers or semiconductor producers, right? So let's think of it this way. If you built a firmware for, let's say, Atmega, you are stuck with the Atmega MCU, right? You cannot easily port your firmware onto something like an ST microcontroller from ST Microelectronics. Neither can you port it to something like an NRF from Nordic Semiconductors. So by investing only in these manufacturer specific platforms or frameworks, you are sort of logged into their way of doing things and also getting your product out there only using their boards. This is what the Zephyr project is aiming to solve, and it does that pretty well. Apart from helping you to target multiple microcontroller units or boards with your code base, it's also a complete real-time operating system. So it helps you to schedule tasks, create threads, and have your firmware run different units that focuses on different aspects of what the firmware is supposed to deliver. From a very high level, this is how I'm going to explain it to you. If you write code using the Zephyr OS or the Zephyr framework, right? What's happening is that they have public APIs that are loosely tied to how things are actually supposed to be done on a microcontroller. So, for example, they have their own APIs for controlling GPIOs, they have APIs for controlling I2C devices, UART, SPI, and all the different communication protocols that you know, right? Now, they do not tie it to how these protocols are supposed to work specifically on any microcontroller. Instead, you write your code using these generic APIs, and the build system, the tool chain, is going to convert the code you write for Zephyr toolchain down to the code that is actually needed to run on the board, your target board. So when we start getting our hands dirty, you'll see that when we are building, we tell the build tool the kind of board we are building for. And this is going to determine even the tool chains that Zephyr is going to depend on to translate your code into the binary format that is fit to be run on your computer. So on the microcontroller, sorry. So let me give you a concrete example. Let's say you write code in Zephyr and your target is for an Atmega. What's essentially going to happen is you write using their public APIs, and then you tell the build tool that you want to compile this firmware for Atmega. And it is the work of the tool chain, the build system, to look for the appropriate tool chain. So you have to install the tool chain that is needed for building for your target, which is Atmega. If you're targeting STM32, then you have to have the tool chains that you will need for ST microcontrollers. And if you are targeting something like an NRF, then you have to install the NRF Connect SDK. This is what makes the Zephyr project interesting and worthwhile. So, for those of you who have done mobile development before, one way I can help you to understand the goal of the Zephyr project is think of it as the Flutter for embedded systems. The same way with Flutter, you can write one code base and deploy it on Android, iOS, Windows, and any other phone out there. Zephyr project basically aims to help you achieve the same. And one other important thing that I like to mention here is that it doesn't really take any control out of your hands. Um, I am heavily invested in ST microcontroller and programming, right? So I know how to do things using ST HAL, and also I know how to do things at a bare metal layer. What I have found with Zephyr is that it doesn't get in my way. If I want to go so low to bare metal, it's basically just defining register addresses and then using bit manipulations to manipulate them. But the beautiful thing comes when I want to switch, or I want to port the firmware from one MCU provider to the other, then I literally do not have to change a lot of things. And that's the beauty about the Zephyr project. So I hope this helps you to make the decision of making it your go-to framework or project for building embedded firmwares. Thank you, and I will see you in the next video.